Hi everyone. So today we will be solving Leetcode problem number 169 among the top 100 liked problems, that is majority element. So the question is, we are given an array nums of size n and we have to return the majority element. So majority element is that element which appears more than n by 2 times, that is more than half the size of the array times in the array. So we have to assume that majority element always exists in the array. So our first approach will be to create a hash map. So in our hash map, in the key we will be keeping that element, and in the value we will be storing its frequency, how many times it occurs in that array. So every key will be unique and we will be storing its frequency alongside as their value. So in this array, when we loop through it once, what we will find is 1, it is occurring 1, then we are getting a 1 again, so we will increase its count to 2. Now we are getting a 3, so we will insert it in our hash map and we will give it a count of 1. Now we have a 2, so 1, we are getting another 2, so we will increase its count by 1, that will be 2. So now we are getting a 3, so now our count value of 3 will increase by 1. We are getting another 3, it will increase by 1. We are getting another 3, it will increase by 1. We are getting another 3, it will increase by 1. Now we are getting a 2, it will increase by 1. So in the end, we are left with the elements and their count value in our hash map. So what we will do is we will iterate through the loop again and we will check which of these elements count value is equal to n by 2, and then we will return that particular element. So in this, as we are looping through the array twice, our time complexity will be O of 2n, that will be O of n, and our space complexity will be O of n, as we are using space, extra space for the hash map, and as the size of the array increase, as we get numerous unique elements, so the size taken by the hash map will automatically increase. So for the approach of the hash map, what we will do is we will create one and we will keep n equals to length of nums by 2. Now let's iterate through our nums array and we will keep a count for every element. So if the element is not there, we will insert it. Sorry, dot get. If the element is not there, we will insert it and we will increase its count by 1. After we are getting the count for every element in the array, now we will loop through the array again and now we will check if our count value of those elements is greater than n here. We could also write we could also write this part here instead of n, but so if it will be greater than n, then we know that it's our majority element, so we will be returning true. Sorry, we will be returning that element. Okay, else we will get out of the loop and we don't have to return anything because of course there will always exist a majority element is what they have given. So let's run this and check for any bugs. Okay, we got our test cases accepted. Let's submit it later. So yeah, it got passed. Now let's see another approach. Another approach to solve this problem is by using Boyer-Moore voting algorithm, which takes up just constant extra space, where we track our majority element in a single variable and we use count to do that. So the intuition behind the problem is when our when we are finding similar elements, that is when our result will be equal to the current element, we will increase the count by 1, and when our result will be not equal to the current element, we will decrease the count by 1. So when our count would be 0, like while we will be reducing it, like we found a dissimilar element and we are reducing it, so when our count will be 0, what we will do is we will update our result, which is the majority element. We will update it to the current element. Now why do we do this? So if we are increasing the count value of an element, like let me use another pen, blue. So in this case, if we are considering this part, so what will happen is we found similar elements, so we are just increasing the count. Now when we find a single dissimilar element, we are decreasing the count just by 1. So here first count will be 2, then when we decrease it, our count value will be 1. So our count value is not yet 0, so we cannot replace the majority element to 1, and in here we see that our majority element is not 1. Now let me show you another example. So what we will do is, if I consider this array, what will happen is our count will be first plus 2 during this 2, then it will be minus 2 during this. So our count will be 0. Now array like this cannot exist only. It cannot exist because our majority element is something which must occur more than half the size of the array. Now we don't have a majority element in this case, which is correct. Now if even if our count value is 0, we cannot update it to result, because in the next iteration, when we will update our majority element, we are not getting that next iteration. So if we are checking, like if I just not take this array right now, if I take up till this, what will happen is first our count will be till 2, then it will be minus 2, which will be 0. Now when our count will be 0, here our count will be 0. Now when our count will be 0, we will just be updating it. Like now we will update, because now when our count will be 0, we will be update the result to the current element. So we'll update it to the current element. So now we know that we have a majority element, because that is occurring more number of times. So let's try and see a bigger example. Like if we see this above example, so let's first write the conditions. So our condition is, if our count is 0, we will be updating our result to current element, right? And if our current element is equal to result, Then we will be updating the count by 1. If our current element is not equal to result, we will be reducing our count by 1. So let's see with this example. So firstly, our count is 0. We will set the first element like we will set the result. Let us set with just 1. So what we will see is, now we come to this condition. Is our current element, like the first element, is our current element equals to result? Yes, it is. So what we will do is we will increase the count by 1. Now we will go through the loop again. So we will be coming to second element. So in the second element, is our count equals to 0? No, it is not equals to 0. Is our current element equals to result? Yes, our current element is equal to result. So we will increase the count. Now we will come to third element. So again, is our count equals to 0? No, it is not equals to 0. But is our result equal to current element? Yes, our result is our result is not equal to current element. So we will be reducing it by 1. Now we will come to fourth element. Is our count 0? Our count is not 0. Is result equal to the current element? No, it is not. We will be reducing it by 1. Now, when I come to the fifth element, is our count equals to 0? Yes, it is equals to 0. So, first we will update the result. After we have updated the result, what it will say is our current element equal to the result? Yes, our current element is equal to result. So, we will be increasing the count to 1. Now, when I go to this element, what will happen is my count equals to 0? No, my count is not equals to 0. Is result equal to the current element? No, they are dissimilar. So I will have to reduce it to 0 again. Now when I come to this iteration, is my count equals to 0? Yes. So what we will do is I will update the result. So after I have updated the result, it will say, is my result equal to the current element? Yes, it is. So I will increase the count. Then when I loop and I come to here, is my count equals to 0? No. Is result equal to current element? Yes. So my count will be increased. Then is my count equals to 0? No. Is result equal to the current element? Yes. So it will be increased. Now when I come to the last element, is my count equals to 0? No. Is result equal to the current element? No, it is something different. So what will happen? We will reduce it. So what we will get is, we will get count is 2, but result is 3. So we have already found our majority element which is existing in the array. Now what did we take? We just took constant extra space, and that is it. And we will be running the loop only once. So therefore our time complexity will be big O of n. So that is how we are solving majority element algorithm. Now let's head over to Leetcode and see how we code it in Python. So for the Moore algorithm, first we will initialize count. Then for each element in num's array, first we will check if the count is 0. If the count is 0, we will reset like we will update our result to num. Then the next part would be if our result equal to num, like if our uh, result whatever we have in our current majority element is similar to our last element, Then we will increase the count by 1, else we will reduce, if it is a dissimilar element, we will reduce the count by 1. Then we will just return the result, which is our majority element. Then let me run this. Let's submit it. Two of the approaches, you can see the memory beats 93.7%. So yeah, that's it. And thank you for watching this video. I'll see you in the next one.